What is Refills about? Refills is about developing novel mobile robotic systems that work in close and smart collaborations with the humans. And this allows addressing the main in-store logistics for retail stores, leading to a smarter shelf refilling in supermarkets. We have an average funding of around 4 million during this 3.5 years that have become 4 years. And the partner to the projects, besides ourselves, Create Consortium, are 2 academic partners, University of Campania Luigi Vanvitelli and University of Bremen, plus 4 industrial partners, and these are KUKA, Swisslog, Intel, and the crucial partner, which is the end user of Refills technology, and this is Drogerie Market, DM.
When I'm looking into our distribution centers, then I recognize that we have a lot of technology in place there. But when we look into the stores itself, then we see that we have a lot of manual tasks without any automation support, and that was the starting point of Refills. When analyzing the logistics process in our company, we recognize that more than 50% of overall operational logistics costs arise in the stores itself. And that is why we really see great potential for the application of automation technology in the very manual environment of the bricks and mortar retail stores.
The big novelty here is to bring the action, which is very much at the center of the definition of robotics as the intelligent connection between perception and action. So with Refills, we also bring the manual action, but the manuality is replaced by robotic assistance. So the idea is to have some manipulators which may interact with the workers in the supermarkets.
A lot of other retail companies will be highly interested in the results of Refills and what we found out during the project phase. And I'm also sure that in the future, when we will look back, that we can say in the end that Refills had a great impact on technology application in bricks and mortar stores.
If you look at the field of autonomous robotics and in particular AI-based robotics, the retail stores are an exciting application domain because they are more structured than home environments, and I expect that lots of the AI technologies will come into practical applications through environments such as retail stores.
In the Refills project, we were looking at all conventional in-store logistics processes, all the way from shelf monitoring to store delivery to shelf refilling. Shelf monitoring mainly consists of data gathering processes, making sure the layout of the products on the shelf is correct, as well as the inventory of each product. When receiving new goods, the pre-sorting of goods in the backroom as well as the distribution of those goods to the shop itself are crucial. The shelf refilling is both a time-consuming and physically demanding process that is still completely manual. The Refills project aims at developing robotic systems able to address the in-store logistic needs of the retail market. 3 scenarios building on top of each other are considered. In the first scenario, mobile robots inspect shelves and generate semantic environment maps for layout identification and store monitoring. The second scenario employs robot arms for autonomous sorting of cases from mixed case pallets in the backroom, autonomously transporting trolleys from the backroom to the shop floor, and for assisting human clerks with shelf refilling. In the third scenario, research thrives to handle a wide variety of products and refill shelves autonomously.
My name is Kurt Leske and I'm working with Swisslog. Swisslog is building distribution centers where pallets are built for stores and the pallets are planned individually for stores.
My name is Jan Devischer. I'm software engineer in Swisslog and I was in charge of the development of the SMS.
The store management system from Swisslog, which is based on Swisslog Sync software, is the connecting software for all modules. For example, giving Depaltizing Cell carrier modules or trolleys or scanning and pointing modules connection point. Each of these modules is individual, but the store management system combines all of these together to make the whole system working. The SMS also gives a connection to an existing ERP system so that all stores can be scanned or can be managed via the store management system and the connections to an ERP software.
In order to build the semantic store maps, you first of all have to equip the robot with knowledge. The robot has to know how shelf systems are composed of their parts. So we have to tell the robot something like there is a base of the shelf system and that there are individual shelves, and the individual shelves are mounted at the shelf system in horizontally, and they are mounted at the back of the shelf, and that each shelf has separators and barcodes that basically tell which products are at that particular place. And then the robot has to take these informations and compute a plan on how it can recognize shelf system in a supermarket. So by doing that, it derives, for instance, that it first has to find the shelf system itself. If it has found the shelf system, it knows there should be individual shelves horizontally at different heights, so it scans the shelf bottom to top, and then it finds the individual shelves, and now it knows that in the individual shelves there should be separators and barcodes, so it basically scans horizontally to recognize, to detect and recognize them, and then when it knows which object is supposed at each facing, then it looks for the products itself. So the strategy of scanning can be derived from the structure that we have given the robot as a prior knowledge.
At Intel Movidius, we worked on identifying and counting the products on the shelves. In order to do this, the University of Bremen provided us with the 3D scans of the product to create a synthetic dataset for both product identification and counting. This dataset was then generated using Intel's Osprey renderer. We also created real-world dataset from DM Store in order to validate our product identification and counting methods in the real-world setting. For product identification, we start with the product image captured by the robot. Using AI, we convert it into a feature vector, which is essentially a sequence of numbers that identifies the content of the image. This feature vector is then compared with the feature vector of all the products in the database that we showed before to identify the correct product. Similarly, we use the state-of-the-art AI to look at the rows of the product on the shelves and count the number of products. Our AI is robust against other visible products in the image and densely packed products.
So semantic store maps are a very exciting representation of stores because they are very realistic, they are very detailed, and you can look at them from different perspectives. So for one thing, you could take a semantic store map and have somebody kind of, when we render them in virtual reality, and simply go shopping in semantic store maps, right? Or you could also think of a system like a Siri agent where you can just ask questions about the store, and the semantic store map could visualize the answers to these questions. So there are lots of applications that you can target if you have semantic store maps available. The main result is that we could show our basic research outcomes and apply them to real-world applications, and this is important because we want to build digital innovation platforms and ecosystems around the technology of refills.
Another module that was developed from scratch in the refills project is the scanning module. Its purpose is to scan automatically the shelves with vision technology. And the platform basically consists of a retractable linear axis that can reach from the bottom level to catch the lowest shelf levels up to about 2.1 meters height to capture the products on the top level of the shelves. The module itself is passive. It will be moved around by docking the carrier module underneath, but the linear axis and the pen tilting camera head are active moved.
The depaltizing cell is a new concept that combines a visual system with a new design of a mechanical gripper that allows the depaltizing of heterogeneous pallets in a completely autonomous way. So without the intervention of any operator during all the process, from the identification of possible boxes to be grasped up to the delivery on a trolley or on what you need in your process. The depalletizing of these homogeneous pallets make different levels of difficulties on the perception side and also on the robotic side. On the perception, because you have a lot of variety of possible boxes, so you need to be robust with respect to very different boxes, and this is not easy at one can think to be, but at the end it's very complex. And the second problem is that boxes can be of different sizes with different different position, close one to each other. Some boxes cannot be grasped from the top, but needs to especially be grasped from below. And so all these difficulties make the depalletizing of heterogeneous pallets a very challenging operation in logistics. And this is why Refills is the first project that provide a reliable solution for this kind of problem. The new gripper that we developed is special because allows to adapt to different sizes of boxes and also allow possible grasps in different directions. For example, not only from the top, as is typical for other kind of grippers, but also lateral. So by grasping boxes from below, so in a way that if you have a heavy boxes or boxes that can be opened involuntarily, for example, if you grasp from the top, this cannot happen because you grasp by holding the boxes from below, from the below side. So this allows to have safe graspings for any kinds of boxes. Even if the depalletizing gripper is a prototype, but the different level of sensorization that we introduced in this system make this reliable from the beginning.
Within the project, we developed a carrier module, which is an autonomous platform developed to transport any module that we have in the scenarios from A to B. The carrier module was developed from scratch in the Refills project. Therefore, it's a very small building platform which can squeeze underneath every module. And it is an omnidirectional platform so that you can maneuver in very narrow areas. The carrier module is an autonomous platform that includes also an autonomous docking application which allows to dock the carrier module to other modules in an autonomous fashion so that the whole application from docking, bringing modules to their destination is a complete autonomous process. In scenario 2, the collaborative shelf replenishing scenario, we added a pointing device which is helpful for untrained clerks to find the spot where they should fill in certain products. and it helps to speed up the whole replenishing process.
In the collaborative shelf refilling, heavy boxes have to be handled, and with our robot we are supporting the clerk with the critical tasks. The robot is handling the heavy boxes with pushing and adjusting them to a proper height for the clerk so that the products can be refilled by the clerk easily.
This robot places the case with the products at an optimal height and suggests the optimal refilling procedure from an ergonomic point of view. The system is tailored to the anthropometric characteristics of the specific clerk in order to reduce the risks of muscular skeletal disorders. To develop this system, we have carried out an ergonomic analysis of the refilling task by doing experiments and massive simulations using digital avatars.
Since we have special requirements which are caused by the environment, it was necessary to develop a novel kinematic. A 6-axis standard robot would not be capable of handling the products without a collision. This is the reason why we designed and developed a completely novel kinematic from the conceptual design up to the mechanical and electrical setup. We are using the different advantages of our technologies to have a proper system that suits the requirements that are given by the environment of the DM store. This is a robot kinematic that is used to fulfill 2 different scenarios. The basic idea is to have the same setup in different configurations. For the collaborative scenario, we have a SCARA-like robot arm, and in addition to that, 2 actuated lifts on the handling module.
We believe that the human-robot collaboration is meaningful only if it allows to improve the efficiency of the process by improving the working conditions and by preserving the health of the human workers.
So in the scenario 3 of the Refills project, the main objective is to try to perform the restocking process of products in a supermarket using a robot like this. One of the main challenges of this objective is the need to manipulate a lot of different objects. They have different weight, size, shape, different surface properties, and even for a human being it's very challenging to manipulate them. You can imagine that doing it with robots can be very difficult. Another big challenge of the replenishment task using a robot with so large gripper is to fit objects in these narrow spaces, and it's really a challenge. These require specific technologies that rely on tactile sensing and also on visual sensors. Our robot is equipped with this standard industrial gripper, but we enhanced this gripper with tactile fingers and with a depth camera. With the camera we can detect objects, with tactile fingers we can feel the weight that is completely unknown to the robot, the weight of the objects we are going to manipulate.
We are able to combine visual and tactile sensors in order to do our in-hand manipulation maneuvers and correctly grasp the object on the pick tray and execute a pick and place task. We use the camera to detect the object on the shelf, basing on artificial intelligence technique. Instead, we use the gripper and the tactile sensing to change the orientation of the object between the grippers. For example, let's take this object. We are able to change the orientation between the object and the gripper doing the so-called gripper pivoting maneuver. That means change the orientation of the gripper while keeping the object fixed in the space. Another in-hand manipulation maneuver that we can do is the dual one. It's the so-called object pivoting. We keep the gripper fixed into the space and we let the object rotate in hand so that to change its orientation. Both in hand manipulation maneuver are model-based, so we don't use artificial intelligence on this kind of stuff, but we use only a model of slippage between the object and the tactile fingers.
And we combine that with our knowledge representation and semantic task specifications, and together we could go and basically place selected items at the right place in the right way into the shelf system. And if you think about the complexity of taking an object and putting it at the right place in the shelf, you notice that there is a lot of in-hand dexterity and feeling that you need to have in order to place the objects in the right way.
For the autonomous scenario, the last link of the robot can be replaced by an actuated wrist. The wrist has 3 additional degrees of freedom and is equipped with a gripper so that single products can be manipulated. For that scenario, single products are standing on top of the trolley levels and they can be grasped by the robot and manipulated to the shelves.
The results were not only technical but also social from our perspective, because we had very positive experiences of working together in that international research group. So I'd like to say thank you to everybody that was involved in that group.
What I liked on Refills was really the fact that it was not only a research project, it shows real practical things in the store and how to improve the efficiency of the store.
What I liked was the combination of the two very different methodologies that were artificial intelligence based on convolutional neural network and automatic control methodologies that are based on physical models.
What I really like and what I really enjoyed in Refills is to have academic and research partners to work together with industrial partners, and the goal has been to take this technology for the benefits of both the companies, like say the supermarkets, and the customers. We are in the world of online technology, but the sensory experience of choosing goods for the customers is crucial, because this is really orientating the taste of the customers. So with Refills technology, we can make this happen in the real stores.